All right, I know there are a lot of exciting conversations going on. I had some really nice ones myself. Being into AM a little bit, this couple of years has really opened my eyes to this industry. Now, NAMIC's SIF for the past 5 editions, 3 of which I'm in, has helped AM startups propel their innovations to the next stage. Now, likewise, for this year's SIF, we will have our 11 startups showcase their solutions. I hope you guys are ready. Taking a deep breath. Now, amongst the 11 of them, 3 of them will be selected today to receive support for their projects, with the second runner-up and first runner-up entitled to NAMIC funded project grant of up to 28 grand and 100 grand respectively. And of course, the first prize winner will have a project funding of up to 280 grand from NAMIC and $20,000 grant from Enterprise SG. And of course, they will also be fast-tracked to Slingshot 2024 as a top 50 finalist. So I hope you guys are ready. No worries. So making this very difficult decisions for us, we have our panel of judges today, Cyril, Julian, and Donna, who we have spoken to just now. And of course, along with them, we have CK Tan, Managing Partner at Green Willow Capital Management, Dr. Jean Cho, Partner at Valuance Ventures, Mr. Asushi Taira, Co-founder and Chairman at The Edge Of and Managing Director at Mistletoe Singapore, Tui Meng, Advisor at Family Offices, and of course, last but not least, Dr. Ho Chaw Sing, CEO of NAMIC. Please give them a round of applause. Now, presenting the 11 startups that will be presenting today across the 2 sessions, we have 1000 Kelvin, 3DK Tech, Castomize, Cellwave Technologies, Circrete, Factorem up for the first session. And in the second session, we have Fehrmann MaterialsX, Pelagus 3D, Qarbotech, REVIVO Biosystems, and Syenta. Please give them a round of applause. Now, startups, before we begin, these are the rules of the pitching. You will be given a total of 10 minutes for this segment, 5 minutes for presentation, followed by 5 minutes for Q&A. At the 4th minute of both the presentation and the Q&A segment, you will be reminded that you have 1 minute left by Wei Fen sitting at the back. So just take a look. Yes, she's right there. And when time is up, you'll hear my lovely voice telling you time is up, and you'll see a red sign over at the back as well. And you are to end your pitch and wrap up the last Q&A. Any questions? No, amazing. With that, I would like to quote Dr. Ho, wishing everyone the very best in your startup journey. And let's begin. Now, first up, we have 1000 Kelvin. Now, 1000 Kelvin helps additive manufacturers reduce the time and cost of printing high-quality metal parts. The company's Amaze software is the AI co-pilot for engineers and uses machine learning models to predict print issues upfront, perform corrections directly in the print file, generating industrial-grade, ready-to-use print files that are perfect on the first try. Now, to speak to us more about that, please welcome founder and CEO of 1000 Kelvin, Dr. Omar Fagani.
Thank you. Thank you very much. Very excited to be here. Thank you for the invitation and thank you for the panel. Very insightful. My name is Omar and I am the CEO and co-founder of 1000 Kelvin. And we're a Berlin-based company in Germany. And at 1000 Kelvin, we truly believe in the power of additive to revolutionize production. But we also know that additive manufacturing is broken. It is estimated today 1.7 billion US dollars of waste related to print failures, material waste, inefficiencies, etc., that we are losing. And the question for us is obviously, how can we solve that? So when you look at obviously the challenges that the industry is facing, well, there are 3-4 key points that you need to know. The first one is obviously the print failure. We're talking about manufacturing after all. And when we talk about manufacturing, we're talking about high yield, high repeatability, and scalability. In additive, unfortunately, we are not yet there. This comes also from design complexity. We tell people design is for free, you can print everything, but maybe that's not fully true. The companies who are investing in AM are suffering financially because of cost uncertainty. They're not able to price correctly, they're not able to protect their margins because they don't know the complexity of their process and they wish they knew it upfront. And last but not least, this is something we see massively, is the expertise. Although AM is a digital manufacturing, just buy a system, print, and it's print, send the file and print. That's not true. You need experts. And these experts play an important role. And every expert has a different approach, and that leads also to different issues. So ideally, this is where we want to be, and we will be there. But unfortunately, today, we're still here. Trial and error is really blocking our industry. So that's why we built Amaze. And Amaze is a first AI platform, and this is the last time you will hear AI in my pitch, that is actually really looking at the core of the issues from the moment our customers get the order. What is the problem with this part? Can I understand it? Is it distortion? Is it overheating? Is it a shrink line? I need to know that upfront so that I'm able to quote and estimate my price precisely so that I protect my P&L. After that comes the alchemy part, where the expertise is needed, where the engineers spend a lot of time. We fully automate it. We use physics-informed technology to do the work, and we are able to generate support structures, orient these components intelligently using the physics behind. And last but not least, and this is my favorite word, is the recipe. Manufacturing is a recipe process making. And here, we are the first company in the world that is able to generate recipes that are intelligent for additive manufacturing. All these technologies are based on, as I mentioned, our patented, protected, AI-based physics software. And obviously, the proof is in the pudding, as we like to say in our industry. How does that translate? Well, this is a typical journey. You submit your component, it's a casted part, and you want to have it next day, 3D printed. Unfortunately, not as easy as that. You receive the part, you do some work, you fail, you try again, you call your contractor, your customer, you iterate. At the end of the day, it's not only waste of time and money, it's also repeat business. Your quality is not there and you're delayed. And what we're talking about, and this is what's happening today, is a technology that is driving the thing end to end for you without you having to take care of the details of the manufacturing. And that's our vision, and that's what we deliver to the customers today. Obviously, this is my favorite slide. No, I'm joking. The market is really niche, but we love that. Why is that? Number one, we're in metal manufacturing. This is a massive industry. It's sticky, and it's a niche, which is, for us, perfect. We know what we want to do. We have a clear path. We're just going to execute, and we have a long-term vision that I'll talk about. But the opportunity is massive because this is one of the few segments that is still growing consistently 20 to 30% year to year. So we have a plan for this niche, and we want to dominate it. Now, we have customers, paying customers. They give us a lot of pain, by the way. It's not easy. We had worked with these leading companies. And some of the achievements I have put here. With Rocket Lab, this is a space launching company based in Los Angeles. We have helped them reduce up to 30% the time to market for some of their neutron components. Rockets. Emerson, an oil and gas company, now is able to print part they couldn't print before. And finally, FKM, the leading...
And your time is up.
My time is up? Okay. I didn't see the 1 minute, though. So basically, I should stop now.
Maybe we'll skip it to the, finish the last side.
So, I think the most important is the team. We are 8 people now. And Katarina and myself, we have done it multiple times. So we have built software that is sold today, and we are doing it again. And actually, we're raising 2 million. We have 80% completed the fund, the request. So yeah, thank you very much. I look forward to the questions.
Yes, and over to the judges. Yes, judges, over to you for the questions.
Well, maybe I'll start. Thank you so much for the presentation. Just can you give us a sense of, it seems there's, even in Germany, I met companies like 3D Spark that similarly can, advise corporates on how to print and then, or manufacture using other types of methods. Where's the difference? I do feel there's been quite a few companies that have in the space. Some claimed AI, some didn't, but it seems the value chain is pretty well understood. Thanks.
Spark AI, you said?
No, a 3D Spark is
3D
one I
Spark.
met, but there's other in Israel. 3D is probably the one I
Yeah,
met.
so there are a lot of companies that are doing the workflow management. How do we take an order to print? But we are more in the process. Now we have a part, how can we make it printable? So it's more about the physics and the knowledge of the manufacturing. So it's a totally different, yes, you're right, it's in the software value chain, but we are focused more on the process know-how. Now we have the use case, how do we print it? How do we print it first time right?
Again, just to say, I do feel there's companies that are also doing that. And so when you launched, did you find that you had competitors specifically doing what you're doing or not?
I mean, yes, there is competition, and it's the old way, trial and error, all traditional software. I used to build and sell this software at Siemens myself, so there is a lot of software out there that people are using, but it's the inefficiency part of it. That's why we want to automate and bring intelligence.
Key question. You said it's a physics-based model. What is the data set? Do you have any unique data that you...
So we use physics solvers, numerical solvers. We generate our data. Our core team, we're 8 people, most of them are physicists, and that's our core business. Our IP is how do we generate this physics data, and we train these models. So it's physics solvers. Yes?
So in that sense, your AI is not exactly current foundation model. It's more like a physics-driven analytics-based AI. That's
Absolutely.
our uniqueness.
We don't do foundational models. We do physics-based. We generate physics data and we train this foundation. You can call it a foundational model for LPBF.
Yeah, that's fundamentally different. Okay.
Yeah.
So given that there's, it seems like the modeling is largely based on the team know-how,
Yes.
how do you protect that know-how within the company?
Well, we have submitted multiple patents. And to be honest, this is so complex that I wish anyone to try to reproduce this. But yeah, I mean, we try to cover the patents on the workflow, but within the team, we are not training our data on the cloud. We have local servers here in Berlin. So we try to have a different approaches to protect our models.
So would you be able to detect if another company were using your technology that you teach in the patents?
From a model perspective, I think no, honestly. But from a workflow, yes. The workflow, the way we do solve the problem for people was what we patented. So we would see the workflow, and that's what we protect.
Can you explain how you are going to move somewhere up the value chain, like the welding part or the CNC part?
Yeah, that's a great question. So in essence, what we do is not really specific to additive. Any manufacturing process requiring energy, movement, tool path forces could fit in our way of building these models. And we know how to build it for welding. It's the same as additive. And we are very excited to move to CNC. But at the moment, we got a lot of feedback from our early customers, and we think that we are really getting close to the PMF. We want to still focus on the niche. But the method is translatable, generally speaking.
Yeah. Do you aim to achieve a perfect design or a cost-efficient design and then supplement with post-secondary operations?
We don't touch the design. So the customer defines the design. We just generate the recipe for it to be produced at the highest quality. So we're more like the recipe generator rather than the design generator.
So most of our clients now, are they aiming for prototyping or are they aiming for mass production?
What we see is a lot of prototyping, to be honest. And one of the issues that is stopping them from scaling or doing serial production is the repeatability, the yield. Those are the issues that blocks them, the cost of engineering. So if we can reduce that by doing more automation, increasing the quality, repeatability, we can help them. That's the ambition.
Thank you.
Can you elaborate a little bit about your business model? How are you going to grow your revenue?
So at the moment, we want to really stay within what the customer is, large companies are buying, traditional engineering software. So we're on a subscription-based, yearly-based model. This said, we are trying to be flexible with our customers. Some come to us and say per use or pay as you go, and some come and ask us for service. So at the moment, we are flexible, but still focus on that software SaaS component.
Yeah, I was just I was just trying to ask you about the business model. So from your market survey, what is the sweet spot that normally customers would like to engage you or to procure your solution?
Yeah.
Is this going to be on monthly, or because a lot of these things are very typically project basis, right?
You're absolutely right. I myself was a mechanical engineer, and I think the best way for mechanical engineers to consume our technology is not to touch it. I am on my CAD system where I do my design, traditional software like Autodesk or Siemens, and I just want to print, and there is a technology behind that is managing for me all the complexity. So where we stand is really within those software, large companies that are selling those softwares already. So this is, I would say, our ideal sweet spot. And by the way, that's why we really focus on lots on partnership with these companies, doing deep integration with Autodesk, deep integration with Siemens, so that we can enable that.
Very good.
Thank you, Omar, for the
Thank you
answers,
for the
and
questions.
thank you for the questions. Let's give him a round of applause. And next up, we have 3DK Tech. Now, 3DK Tech is changing the way metal manufacturing works by creating a metal additive technology that can match traditional manufacturing methods such as forging. Now, they aim to increase the resiliency of supply chains and the agility of industries such as the aviation and energy maintenance sectors. Now, to speak to us today, please join me in welcoming co-founder and CEO of 3DK Tech, Dr. Alexandru George Telita.
Thank you. Hi, I'm Alex, the co-founder of 3DK Tech, and we're miniaturizing forging techniques. Now, you might be aware of this, but Airbus and Boeing are not really delivering a lot of planes, and that's creating a problem, which means that the aircraft currently on the market need to stay on the market from 20 years up to 50 years. But to do that, we need spare parts to keep them flying. Problem with getting new spare parts is we don't have the manufacturing capacity to do that. 3D printing would have been an awesome choice for that. It's agile. The problem with that is, there we go, 3D printing is not reliable. Metal 3D printing specifically. It's very hard to get the right durability and reliability. Partly because there's a lot of cracks and pores in the internal structure. Now, forging is what is usually used to manufacture components of high criticality. And we combine the two, 3D printing and forging, into a technology that can reach the same durability and reliability as forging. We do that using ultrasonic vibrations. Whenever ultrasonic vibrations have been applied to other manufacturing technology, we've seen improvement by an order of magnitude to 2 orders of magnitude in quality, whether it's productivity, grain refinement, or fatigue life. And this is exactly what we've also seen with our preliminary results. We've doubled elasticity, we've doubled strength, and increased the plasticity. This is basically the thing that increases durability and reliability. And if we're looking at the numbers, well, we can take this compressor blade assembly. This one part costs between 30 and 80,000 US dollars to make. We can make it 10 times cheaper and 10 times faster while keeping the same durability levels. We're able to do that because we have a great team. I've got 18 years experience in non-conventional manufacturing and a PhD. And my co-founder has 15 years experience in aviation engineering, working in MRO, working with Rolls-Royce and GE. We have a top-notch group of advisors, C-level advisors. And we have quite some traction. We have about 4 commercial-grade deployments that are ready to deploy within the rest of the year, by the end of the year. And that will finally unlock our ability to deliver parts to our customers. We have about 20 customers waiting for our parts. That can generate quite a bit of revenue. Eventually, we want to make our own printers, but that's further down the line. Now, On that, we have pilot programs in both the energy sector and the aviation sector. They all need the same exact thing. They need spare parts for their infrastructure that is old. And we have quite a bit of roadmap, LOIs for up to 13 printers. And like I mentioned earlier, about 20 companies that are waiting. To achieve these, we're raising 1.5 million US dollars. And that can unlock up to $3 million in revenue within 2 to 3 years. And that was me. I'm Alex. Thank you for your time.
Thank you very much. And over to the judges for questions.
Thanks for that, Alex. Can you just elaborate? Do you need any post-processing with this tech that you're...
Thank you for the question.
Like HIP or...
No, that's the beauty of our technology. We're actually able to eliminate all the other extra steps. So after 3D printing metal, you have to go through stress relief. And then if you were trying to increase the durability, you have to do a hot isostatic pressing, and that still will not match your forging level. So we can eliminate all of those extra steps and just 3D print and then cut away the support structure, and you're good.
Could you elaborate a little bit on your material range? I saw stainless steel. Do you do exotic material like Inconel and others?
So that's the beauty of it. It changes the process. We can apply this to any metal alloy. We're benchmarking on stainless steel 316. It's an austenitic steel. But the process itself works on the atomic level. So we use ultrasonics to basically assemble the atoms of any metal in liquid form.
So you're suggesting there's no heat treatment post-secondary?
Yes. We're solving the reasons for existing the stress relief and hot isostatic pressing. We're solving them from the process straight away. The reasons you have to do that is because there is some stress built in the process itself. You have high temperature differentials in very small areas, and that causes a lot of thermal stresses that cause cracking. We eliminate the causes of those cracking and pores.
So you're familiar with ASTM?
ASTM. ASTM. Yes.
So you're in compliance with the requirement?
It will, yes.
Thank you.
Any other questions from the judges?
What sort of parts would be really difficult to make?
This. This is a tool that is used in aviation to torque a particular bolt on the back of a 777 horizontal stabilizer. It's very hard to make, and this would cost about 6,000 US. So that plus a few others that have to do with this. So a lot of supports can be applied, and a lot of geometries such as heat exchangers and rocket engines that are very expensive to manufacture conventionally, or you can 3D print them, but they're not going to withstand the loads required in critical applications.
All right, so just on your team expansion, right? So the 1.5 is going to drive, I think you said X dollars of revenue.
3 million up to
3 million. So how would you double that? If could you double that with additional BD, or you're just not ready to take on that level of acceleration at this point?
We could. Basically, the bottleneck for us right now is how many ultrasonic modules can we deploy right now. The more we can deploy, the larger the pool of revenue we can generate, basically.
So is that the formula? So for every 1.5, you can generate 3? Does that scale?
That's a good question that I haven't really thought too much about, but basically There is obviously a bottleneck. We still have to go through the processes of this roadmap that I showed earlier, where you do have to go through a particular set of, for my pilot programs, and we do tools, and then functional components such as seat brackets, and then eventually go to heat exchanger, and then after that, you go into compressor blades that I showed you earlier. So it's about building confidence in our customers that the parts that we can deliver are resilient and can withstand the critical loads that are required.
Quick question. So regarding protection, technology-wise, and of course, you can file the IPs, but is there any kind of because using an ultrasound or using a microwave, there are many similar methods actually. So how can you protect your technology?
So we have a patent already granted in the US, and I'm the inventor of it. And we also build, like Omar, we have our own software that controls all of the process for the ultrasonics to protect that. Plus, we're building other IP as well.
So in that sense, the important thing is that the specific kind of the frequency to use and specific pattern to use, and all those are
those are know-how. Those are trade secrets.
I see.
Yeah.
Okay.
Thank you, judges, for the question, and thank you, Alex, for the presentation. All right, and next up, we have Castomize. Now, Castomize is redefining fracture recovery and limb immobilization. Now, with their 4D printed casts that are antibacterial, waterproof, reusable, and self-molding, it offers patients and practitioners a sustainable and adaptable solution set to be the new global standard. Now, representing Castomize today, please join me in welcoming co-founder and CEO, Abel Teo.
Okay, 3, 2, 1. Just like that, a new bone fracture has occurred, adding to the over 200 million cases happening every year. And you are more than likely to join this club twice in your life. So if you've ever broken a limb, you have to wear a fiberglass cast, and it's very itchy, very sweaty, you can't shower with it. Doctors also face a lot of problems with this process, and it involves over 10 different steps with 10 different tools. So a lot of human error tends to occur. So this is where we come in with Castomize, with our 4D printing technology. So you might be wondering what 4D printing is. So 3D printing, normally you scan, and then you print it, and then you deliver it. But for us, we preemptively scan like millions of data points. I wouldn't say millions, but thousands of data points. And then we basically fabricate a structure that can adapt to all of those data points. And we make this possible through our own proprietary blend of materials, our fabrication method, and also the design method. So with our solution, patients are now much more comfortable. They can shower, they can conduct their daily lives freely. And doctors, they actually are able to eliminate their error rate, as our casts have self-molding properties. So once you heat it up, you put it on, the cast will actually mold itself with the ideal pressure required. So this reduces the amount of tools, and it reduces the amount of waste and time required. So how it works is basically you heat, you put it on, it cools, and then you can reuse when needed. So I can even give a demonstration to you later during the Q&A itself. So against competitors, I would say the most dominant solution in the market is still the traditional fiberglass because they're the cheapest. However, they are also the most uncomfortable, which is why in the past 10 years, many modern competitors such as 3D printing, curing have tried to emerge. So while all of these options are definitely more comfortable, they are also much more expensive, and they require doctors to learn new processes. So for us, we stand out by providing the best of both worlds. We have increased comfort, increased ease of use for doctors, while having a more affordable price tier as well. Therefore, we are best positioned to be the new global standard of casting. So in fact, over the past 2 years since we incorporated, we've sold about 1,000 units, raised about 450,000, gotten certified in multiple medical regions, and we are now finalizing other sales agreements. We have also gotten engineering awards such as the ASEAN Outstanding Engineering Achievement Award. So the market we're looking at is about 200 million cases every year, a $19 billion market. However, we are only focusing on the leg and arm fractures right now. So this does not include other markets such as veterinary, prosthetics, which we are highly relevant for as well. So this is a little bit on the business model. So by 2028, we conservatively aim to heal about 1 million fractures, getting us a revenue of about 50 million by then. So this is a little bit on our timeline. So we are actually now finalizing more sales agreements, and we are aiming to move into the US when we have completed our mass manufacturing, which we aim to complete about 2025. So right now, we are more scalable technology than just for orthopedics. So all of our use cases are actually formed through existing clinical needs. So right now we have about 10 ongoing hospital agreements with local healthcare ecosystems to develop new products, to test existing products. So not just in cast, but for conditions such as cerebral palsy, prosthetics, and even upcoming radiography as well. So this, we are very blessed to have a diverse and complementary team from mechanical engineering, business, and biomedical engineering. And we're also very blessed to have a diverse and very capable advisory board from medical devices, hospital management, orthopedics, and regulatory. So right now we are really seeking for more connections to hospitals, distributors, and we are actually now raising some money to build our mass manufacturing facilities, as right now we are receiving more orders than we can produce right now. So yeah, I've come to the end of my presentation, and I hope for this opportunity to move on to Slingshot so that we can scale higher and establish ourselves to bring the future of additive manufacturing from 3D to 4D. Thank you.
Thank you, Abel. And now on to the judges for questions.
Can you talk a little bit more about your materials that you use? Like you said, it was proprietary, but
it is proprietary. So we actually use 5 different materials in our structure. So some of it we have patented, we have filed patents for, and some of them we are keeping in-house.
Got it. And then I guess that form factor, is it completely rigid, or like, for example, if you had broken your elbow, you can't technically move your elbow, so.
Right, so we have different models. Some for this one is the short arm, and we have an elbow one which is being tested in KKH right now.
Got it. And when you say it's customizable, is it based on, like, what data points go in? Is it like for example, you say athletes, certain athletes might have more stress on their limbs and bearings, so is it customized in that sense, like almost personalized, or is it?
So right now, we are actually tailoring it for the use case of fractures. So we go through data points in measuring like kind of the lengths, the widths of most limb sizes out there, and then we model how our structures will move according to fit most of these data points. So if I can show you a demonstration right now. So it actually starts like this. And with this, you can put it on almost everyone in this room.
So in that sense, this is not exactly personalized. It's more like a common denominator form factor and a fit for many people.
Yes, exactly. So we are scaling up mass customizability.
I see. So in that sense, production-wise, centralized production or decentralized production or in between, what's a plan for scaling, especially?
Right. So we are moving. We're kind of exploring both ways at the same time. So for very simplified use cases like healing fractures and immobilizing limbs, we're able to do a very standardized manufacturing process. But in the future, when we have more complex medical devices, such as artificial organs, we will definitely have to do a very specified 3D printing process that will be focused towards a particular patient.
I see. But well, this is quite good design, but straightforward. But it can be easily copied, the idea itself. How do you defense,
Well, we have a mix of things. So we have filed patents and we have done prior art searches with, for example, some of our patent lawyers. And we have very strong cases in utility patents. So that's number one. And also we have some trade secrets that we are not disclosing. For example, we have built our own 3D printer that can accommodate up to 5 different materials, which is very uncommon in the industry right now.
So this is which class of device?
Class 1.
Class 1. In terms of price point, how does this compare with a traditional fiberglass? It's like 2 times, 3 times more, or how many times?
Right. So if you look at just directly the device, we cost about 50% more, but we are reusable along the patient's healing journey. So normally when you fracture your arm, after 2 weeks, you have to change a new coating of casting because your muscles will deteriorate. So if you look at that, along the patient's healing journey, the patient actually saves more money while having a more comfortable healing experience.
So is this a patient decision or a doctor's decision to use your solution?
Well, it's a mix. So typically what happens in Singapore is the doctors will offer patients a choice. So do you want the customized solution? Do you want, fiberglass? In different markets, I would say patients can go on the website and then they can, learn about our cast and then go to their doctor and say, hey, we want a customized cast.
Maybe you can educate us a little bit. So eventually, if this is all covered by insurance, then 15% additional will be a non-brainer, right? Everybody should just go for it.
Exactly, which is why our demand is outstripping our supply right now.
So we have sold about 1,000 units.
We have sold 1,000 units
That's
already.
over how long period?
3 months, 6 months, 3 to 6 months.
3 to 6 months, you sold
Yes.
1,000 units.
Yes. So we are producing those 1,000 units now.
Thank you.
Thank you.
So just a few questions. Does this change the clinical workflow at all? Does the patient have to wait for this to be manufactured? Is it done on site? That's one question. The second is that you mentioned this is a proprietary materials blend. So has there been any biocompatibility studies with this proprietary blend? And then the third is that the 3 million you're asking for, how much of that is for CapEx?
Right. So thanks for that question. So the first question, which is whether it changes clinical workflow, the answer is it won't, because we are actually just pumping out standardized units. So there is no waiting. We actually stock a standard unit size in hospitals. So there is no need to wait at all. Yeah. And your second question on biocompatibility, we have already gotten the 10993 biocompatibility certification, which also stands to provide us an even better competitive advantage as we are skin friendly compared to the fiberglass solution. And your last question on how much will go into CapEx. So we estimate about 1.2 million will go into CapEx. The rest would be more of our business development, IP filing, regulatory.
And so for that 3 million investment, what is the max revenue you think you can generate from that?
Right. So I would say with 3 million, we estimate that next year we would be able to generate about 1 million in revenue. And then the following year would be 3 million.
Thank you for the answer. And thank you, judges, for the questions. Please give Abel another round of applause.
Thank you.
All right, and next up we have Cellwave Technologies. Now, Cellwave Technologies aims to bring unique value to researchers in personalized medicine with a cell sorter that can isolate the most fragile cells with minimal cell damage, all on their lab benchtop. Now, the cell sorter, which has a small footprint and weighs only 15 kilograms, promises to be a game-changing to workflow with experimental efficiency. Now, to tell us more about this, let us welcome CEO of Cellwave Technologies, Robert Fu.
Can you hear me? Okay. Good afternoon, ladies and gentlemen. What you see here are heart muscle cells that have been induced from a patient's blood stem cells. The patient is suffering from irregular heartbeats due to problems with his ventricular muscle cells. So in precision medicine, the researcher has to isolate out from this mess only the ventricular muscle cells so that he can find cures that will precisely treat that condition. But these cells are very fragile and they're few in number. So he needs to have a sorting machine that can handle fragile cells and for easy access in his own lab. The demand driver for this kind of research is in growing acceptance of precision medicine and the increasing number of clinical trials going up very rapidly, as well as research publications on precision medicine, growing interest in fragile cells. And just from US alone, there are 50,000 labs funded by NIH that's doing related work in precision medicine. Current cell sorters damage, these are mainstream sorters that they damage up to 50% of the cells. They're expensive, generate harmful aerosols, so need to be housed in biosafety cabinets. So they have to be in centralized facilities and need expert operators to operate them for all the different research labs. The problem is this. In this kind of research, you don't really need to sort the cells up front, but also along the way downstream, you have to continue to sort at different time points. And the problem is more acute if the cells are fragile and they're dying outside the natural environment. So this is a product that we have developed.
Isolating cells of interest is a first step in research on single cells. Cellwave sorter is especially designed for you to analyze cells that are fragile. At the heart of Cellwave is a disposable sorting cartridge powered by a patented gentle sorting technology. Fluorescently labeled cells can be detected and subsequently selected using gentle acoustic wave for collection. Sorting using Cellwave is fast and easy. First, load sample and sheath buffer into reservoirs. Put the fluidic cap on the cartridge and then insert the cartridge into cartridge slot. Start sorting in the Cellwave application. Detection and sorting parameters can be set here. Histogram plot shows distribution of particle fluorescence intensity, which can be used to determine target cell gating. User can visualize sorting in action through camera view. Target particles are pushed to the bottom channel while unwanted particles go to the top channel. After sorting is done, sorted samples can be collected for your downstream applications.
So you can see it's very easy to use. And this product, which we built in the last 4 years, has been verified in field tests in Singapore and in China for fragile cells recovery, as well as for cell separation for single cell sequencing, which is a used technique for immunotherapy research quite a lot. But the product that we have now is still this big, bulky, weighs 25 kilos, so it's not really portable. The new funds we are looking for is to build a much smaller product, which will be only this big, 1 square foot footprint, 15 kilos that you can carry around anywhere to do your sorting experiment and sort again anytime. And it'll be priced affordably for most labs to use it. And it can be expanded by modules for bigger throughput. And we are doing this by using optic fibers instead of the optical assembly that you see outlined in red into something that's a cartridge, a credit card size cartridge. And this is where we'll require 3D printing technology to print the laser guides to be able to guide the laser beam and to detect the refracted laser beams. And we're looking for $2 million, primarily for manpower and outsourced fabrication. And with that $2 million, we should be able to reach field testing by the middle of third quarter next year. And when we get good results from internal testing, we'll raise Series A. And the business model will be manufacturing in Singapore, sales distribution worldwide, revenue sources from sale of the sorter, recurring revenue from the cartridges and consumables, and our primary markets are Singapore, North America, and China, through contract research organizations and labs. We hope to get up to 2028, 600 units and 100,000 cartridges. And with that kind of revenue, for a trade sale with, say, 5 times multiple, you would get a 21% IRR on your investment of the $2 million that we're asking for. This is a team that we have. I have some experience bringing a startup to a US company and driving distribution in China, in Japan. Prof. Ye and Dr. Chayakon have a lot of experience with acoustic microfluidics. We have an engineering advisor who's got a black belt in Six Sigma for med technology and a research advisor. So we look forward to your support in bringing this potentially game-changing workflow improvement. It's almost like, if you think in terms of IT, moving from a mini computer age to your personal computers. Thank you.
Thank you. And over to the judges.
How does this compete with some of the other cell sorting devices that are doing fragile cell? Like I know Thermo Fisher recently acquired a company that's doing that as well. So
Yes. Yeah. Well, as I showed, the biggest competition is against the mainstream ones, where we really democratizing the access to the cell sorters, yeah, to a much larger audience, right down to the lab. There are a couple of other competitors but they do not have the ability to shrink down to the kind of size that we want to be really portable because of the intrinsic technology that we have, a very small acoustic microfluidic device that we can then build the detection for the fluorescence right into the chip.
got it. And that acoustic kind of microfluidics
Yes,
is your own IP.
That's our patented IP.
So what is the price of this new smaller format device?
For a single module, which will be suitable for most labs, basically we know what they need. It's 80,000 that we're hoping to sell at, and our cost of goods will probably be about 40,000, and each cartridge about $100 US, and with a cost of about 40.
Mm-hmm. So is the model to sell the unit or to lease it, or how?
Yeah,
what's the?
It can be in both forms. For a lot of research granted research, it may make sense for them to lease it for the duration of their for the duration of their cell collection, data collection, which may be just 1 year. So that probably lends itself better to leasing. And we've talked to companies like Auric and so on. It's about $3,000 to $4,000 a month for them to lease. But for those that have many projects in the lab, they can probably afford to buy for about 80,000, compared to about 400,000 for the big ones.
Right. Okay. Thank you.
Can you share who are your paying customers?
Okay. Today, as I pointed out, the main customers are the large institutions who buy it as a central facility for other people to access. So in Singapore, for example, you have maybe 3 or 4 in Singapore servicing all the research labs, and they have to book in advance and so on and so forth. With this ability to downsize it to something they can carry around, we are targeting the individual research labs. And it's really it's really like moving from mini computers to PCs.
Yeah. So your paying customer, you're like 3, 4, 5, or how many units have sold so far?
We haven't sold anything yet. The one that I showed you, we have completed, is our first generation. It's not compelling enough because it's too big, and I think to be really compelling, we need something that we are aiming to build now, using fiber optics to really shrink it down so that people can really bring it into the labs onto any workbench they want to, instead of having to book some facilities far away.
Thank you.
Is there any application of this in the clinical setting versus research?
Yes. Imagine the day when molecular diagnostics becomes more mainstay. Today is still used on molecular diagnostics, still special cases in university hospitals, especially in the US. But the day will come when molecular diagnostics for cancer and so on becomes more widespread. Then this can be put into any pathology lab on the lab bench for the pathologists to do single cell sequencing for the cells that they collect from patients. When that happens, really it's it's like moving from PCs to laptops.
Thank you, Robert, for the answers, and thank you, judges, for the questions. Please give him a round of applause.
Thank you.
And next up, we would like to welcome Circrete. Now, concrete is the second most widely used material globally, but its production contributes approximately 7% to global CO2 emissions. Now, in Singapore, large quantities of marine clay are excavated during infrastructure projects, yet much of these materials are treated as waste. Now, Circrete aims to address this problem by converting marine clay into a sustainable cement substitute through an energy-efficient process. By repurposing local waste, they offer a greater construction solution while reducing reliance on imported cement, contributing to Singapore's 2050 net zero goal. Now, to introduce us to their solution, please welcome co-founder of Circrete, Dr. Du Hongjian.
Oh, hello everyone. Good afternoon. My name is Du Hongjian, co-founder of Circrete, Circular Concrete. Today, I'm very excited to show you the green cement product made from local waste marine clay.
National University of Singapore researchers have come...
Sorry. To help you better understand this innovation, I want to introduce a very brief clip from the Channel News Asia. I will elaborate more afterward.
National University of Singapore researchers have come up with a new type of concrete that's greener and stronger. It's made with waste marine clay, a material generated from excavation and construction works. Such materials are usually thrown away, but the scientists have found new ways to use it. The clay can replace up to half the amount of sand typically needed to produce concrete. This reduces the need for sand, which can be a scarce resource. The researchers also found the marine clay concrete to be 3 times more durable than normal concrete. They say the new concrete measures up to existing performance requirements. The scientists are working with soil-built construction to pilot the material in an upcoming project.
Cement is used in wide activities, including construction. But the cement and construction industry are facing big challenges. The first one, the cement production emits 3 gigatons CO2 every year, contributing 8% of the global carbon emission. It is 3 times more than the aviation industry. Second, more than 10 million tons of marine clay is excavated in Singapore alone every year. This clay is difficult to recycle and costly to dispose of and transport. So we have developed an innovative solution to upcycle this waste marine clay as green cement. Compared with conventional cement production, our technology allows the carbon emission reduction by up to 70%. And also, it can transform a large quantities of local waste as value-added products. So 2 big problems can be solved at one solution. The global green cement market size is valued at 41 billion Singapore dollars, with Asia-Pacific region market size as 10 billion. Our obtainable market in this region is about $400 million, and the long-term market in Singapore is about 10 million Singapore dollars. Our business model is B2B. First, we collect waste marine clay from earthwork companies. Second, we produce and sell the green cement to concrete companies. Thirdly, we help our customers improving their ESG reporting by cutting down their Scope 3 carbon emission. Compared with the existing green cement in the market, such as Flash and GGBS, Circrete can offer this comparable performance, but it can stand out as a more sustainable option. The reason is because the raw material for Circrete is abundant locally and globally. In contrast, the Flash and GGBS has very limited in supply in the short future because they come from heavy emission industry and they also face green transition. Our technology has received tremendous traction. We have received the Excellence Award from Singapore Concrete Institute in 2022. This technology has been well received. As a startup, we keep advancing. We try to incorporate this green cement in 3D printing concrete, trying to solve the problem of construction productivity, which is another big problem facing the industry. More than 20 companies and government agencies has expressed a strong interest to work with us because Circrete has been approved by Singapore standard and safe to use in various applications from building, infrastructure to coastal protection. One pilot project has been successfully implemented with HDB and NParks to safeguard our coast. Look at these beautiful tiles. Can you imagine they were made from the waste clay from underground? So I want to introduce my dedicated team, including Tong Shanshan, Bang Zidai, and Jerry Wang, and myself. Together, we bring more than 50 years experience in this industry. In summary, our innovation provided one powerful solution to address two grand challenges. And this innovation has a big market drive globally. So we believe it's the right time for us to act together to build a greener future. So I won't stop here, and I want to take any question from the floor. Thank you.
So what is the science behind this that give you the strength and structural support? Is it your special concoctions that mix with the raw material, or what's the science behind it?
Okay, the science is we have a lot of clay in Singapore. About 40% of the land surface is the rock formation with clay. This clay has no activity, but with this technology, we transform the inert clay into active clay. So this clay can be blended with cement to make it greener.
So you have your proprietary additive to it?
Yes, we have it.
So that's your...
That's the IP.
That's the IP?
Yes.
The technology an additive, or is it a process, or both?
It's the process. It's mainly the process.
Right. Okay. And so you showed your TAM, your global TAM, multi-billion, but have you used this process with other types of clay or soil from wherever you're going to get this free source material?
Yes, we did this validation. Actually, in Singapore context, the earthwork companies need to spend money to dispose the clay. So in our business model, we collect the waste clay at this moment for free. Actually, it's good for this company.
But outside of Singapore, because you showed a global market,
Yep.
right? So I'm curious how you're going to capture that global market. Do you have to change your process or additive technology to accommodate different input material?
Yes, that's a very good question. In the vision of the company, we want to make Singapore as our R&D center. So whenever we want to expand the business to different regions or countries, we will study the clay from the local context, and we will develop the right recipe for the local concrete quality.
But it will require a redevelopment of the recipe for that new input material.
Yes, so that's right.
Okay, thank you.
Can you explain more about the capex and the opex of in the Singapore context? For example, you mentioned 10 million market, right?
Yes. So this estimation is based on our assumption that 5% of cement in the Singapore market is supplied from Circrete. It's about 10 million Singapore dollars.
Okay, and for that you have to create a factory, right?
Yes.
And how much is that factory?
Okay, so in the plan of the next 3 years, we want to build the medium-sized factory in Singapore, which requires about 1 million Singapore dollars.
Maybe a disclaimer first. We've invested in a company that's doing exactly that in Europe. We've put 20 million to work in a company called MaterialsX in France. They've chosen two different things from you. One is they can use any kind of clay from any source, so not just maritime. So the question is, why only maritime, which is a little bit what Donna was saying. And the second, which is they don't sell directly. They sell to cement manufacturers who they sell them the plant and the recipe. So my question focuses on the second. Why go directly to sell it? Why not sell the units to someone who wants to sell it?
Thank you for the question. This is a brilliant question. I want to answer the second question. In Singapore, no cement factory. So that's why we cannot sell to cement company. We have to sell to concrete company directly.
Okay. That's a good reason. But outside of Singapore, which is where maybe a lot of the market is, what do you want to do? Do you want to be direct, indirect?
Yes, so we will consider both. Yeah, depending on the local networks, yeah, and the company.
Okay. No, thank you.
Yeah, thank you so much.
Any other questions from the judges? If not, thank you very much.
Thank you.
Please give him a round of applause. And now finally we are down to our last presenter for session 1, Factorem. Now, Factorem aims to revolutionize manufacturing supply chains with cutting-edge technology with an AI-powered platform, robust network, and a full host of services. Factorem promises unrivaled efficiency while ensuring top-notch part quality. And of course, joining us today, please welcome co-founder and chief product officer of Factorem, Hardik Dubaria.
Test. Okay, great. Yeah, thanks everyone, and it's an honor to be pitching amongst your companies. I think the stuff that you guys are working on is really useful and solving a problem that I'm also going to talk about. So before I begin, I'm Hardik from Factorem. We're building the first Southeast Asian marketplace for on-demand manufacturing. The market's $150 billion big. There's tons of people facing the problem that I'm about to talk about, and yet they're transacting $150 billion with that problem every day. And the problems with procurement of these parts. Meet Jack. Jack's your typical production manager. Our buyers have production managers. Their job is to get parts that they've designed delivered to them. These parts come across many different verticals. We started off focusing on CNC or precision engineering. Jack also exists, a version of Jack also exists on the supply side. Jack's job on the supply side is to make sure that he is getting sales. Whenever possible, his machines are used at full capacity, making sure his workers have challenging jobs to do and to grow their business. But this is what they deal with on a day-to-day basis. Every day, they come to work, they receive RFQs. Customers send out RFQs, requests for quotes, to get quotations from multiple vendors. These are usually sent along with 3D designs and technical drawings that nobody in the world has seen before. They've designed it, they've simulated it, they've tested it. They need somebody right to manufacture it. Because of that, it goes into a 2-week-long discussion to understand the requirements, making sure the supplier understood what needs to be done, and if there's any communication gaps in terms of maybe language or different ways of interpreting the same thing, clarify. Based on that, we go ahead to negotiate prices, lead time, and eventually we pick a supplier, and the supplier hopes he gets picked. It then goes into production. This can take anything between 4 to 6 weeks. Because this has never been done before, like Omar shared, there's tons of mistakes made and you have to keep doing it over and over again. I think our suppliers would love your solution. Going forward, it goes into delivery. Our clients can come from anywhere. How do you figure out shipment? Jack, the supply side, started it not because he wants to manage all of this. He started it because he's a machinist. He wants to practice his craft. He wants to take a block of metal and carve it into a shape that you want. He spends 90% of his time doing this, not the other thing. And that, despite doing all this, 70% of inquiries he gets, he does not win. What a waste of time. That's where we came in. Factorem built a platform layer that automates all of these steps that we saw. We've been building this for the past 4 years, and today it's operating at a level that we're mostly content with, but there's still more to go, especially in terms of deep research that needs to be done to cover a lot of the edge cases that we don't cover just yet. Starting off with the ability to have a 24/7 live platform that takes in 3D designs along with technical drawings. We then analyze these drawings in order to give design feedback and an instant quote. We match this to the right production factory. These factories all come from Southeast Asia today. There's 150 of them that we've pre-qualified. They then go into quality checks and we ship to doorsteps globally. Till date, we've shipped to clients here in Singapore, but in the US, Australia, New Zealand. 40% of our revenue comes from international markets, 60% in Singapore. This year itself, 70% of our revenue has come from international markets. Not to forget, order again. If a client loves the job, they would love to come back. It's a click of a button. 80% of our revenue comes from repeat orders. Here's a quick preview of what that looks like. It's a live platform. All of you can try it, upload your 3D designs, get quotations. But beyond that, we give you feedback as well because we don't want to deal with quality issues at the back end. We clarify everything up front. The way we manage this is through our own proprietary technologies. It then goes on to also allow you to get target prices. If our price is not good enough, we generally allow you to get a 30% more competitive price because we leverage on Southeast Asian suppliers who are better priced, as well as we tap on spare capacities across our suppliers. Beyond that quality, one thing we also do, and something that I hadn't even imagined we could do when we first started off, thanks to OpenAI, we use OpenAI along with our own algorithms to analyze drawings deeply to make sure we catch every single detail that humans tend to miss. As humans, the more of these drawings you read, the more mistakes you're going to make. And what typically happens is, oh, you missed the fact that engraving was 1 mm deep. It doesn't make you a bad supplier, it just makes you human. And this leads to a lot of rework, and this is normal. This is part of the $150 billion that are transacted. With Factorem, we catch all of these things and create a checklist for suppliers so that they don't miss them. them making a mistake becomes a problem for us as well because we own quality along with them. This is a way to reduce that from happening. 150 manufacturers as well. How do we identify who's the best? We analyze more than 85 parameters on every order and 400 on every suppliers. In order to do matching, the system tells us the best 12 suppliers for every given job, and we pass it to them through a job board. For customers, we give them access to an e-commerce-like experience. This is the Amazon version, but for custom manufacturing, how am I doing on time?
Your time is up,
Okay.
unfortunately.
Yeah, okay, just to wrap it up, our ask is to really meet more AM suppliers because over the past year, we've seen AM go from number 3 or number 4 to number 2 this year. So CNC first, then AM. And we see it growing without us spending any additional marketing dollars. But we don't have the expertise to solve for this yet. So we're looking for industry experts to come in, work with us to improve the platform in order to give customers assurance and take on more of these AM orders confidently. This is our team. We're the largest custom manufacturing platform in all of Southeast Asia, and we hope you can join us, and I'm happy to take any questions.
Sorry if I haven't understood everything, but are you a two-sided marketplace?
We are a two-sided marketplace.
Okay. Is that the cardinal sin of startups?
Is that, sorry?
The cardinal sin of startups, like it's a very difficult thing to put together.
It is. That's why it's been 4 years. So when we first started off, the biggest problem was figuring out what to build first. And we were going everywhere. And I think it took a team of really energetic 20-somethings to be going out there every single day to piece it together. But today we're a lot more established. We don't need to focus on building for both sides. The supplier side is really happy with just getting jobs. They just need a simple platform that gives them jobs every day when they log in. And we don't have to market to them as well. We don't spend anything on getting them on board, except for the quality process that we bring them through. So our focus is purely on the buyer side. Suppliers are joining on a weekly basis now. We get 3 to 5 new suppliers organically. So 100% of our efforts are on the customer side. Yeah, I guess to add on, when we realized that we don't need to focus on suppliers was when we met one of our advisors, this guy, CK Tan. I understand one of you shares the same name. He is someone that has had IPO 2 companies in the past. He's thought of this idea for the past 25 years, and he said he never thought of executing it because it's so tough. When he saw us doing it, he loved what we were doing, but he said he hated how we were doing it. And the reason was because we weren't charging suppliers anything. We were actually grateful for suppliers that wanted to join our platform. But since he said that, we tried this out. We told all our suppliers that you have to give us a 15% commission on every sale you get through us. Every single one of them signed on. And that's when we knew, okay, that we've created enough value. We can focus more on getting more buyers now.
Thank you for the explanation. Any more questions from the judges?
Yeah, last question for me is, does it make such a difference to be regionalized for this business? I mean, there's a few marketplaces, one we looked at in Israel that is, addressing clients in Europe, and does it make such a big difference?
Yeah. Once again, when we first started off, there was a hypothesis we had, and we're fortunate that came true, because it's true. A lot of the capacity over here, they're very well skilled. They've learned a lot from our neighbors in China or India, especially in countries like Vietnam, or in Singapore with high-end manufacturing. A lot of them started in the 70s and 80s, servicing MNCs who are willing to give jobs to anyone good that's out there. But today, that's no longer the case, because these MNCs have started going elsewhere or created new products. Hardware is iterating at a very rapid scale, so they've a lot of spare capacity. We get to tap on this spare capacity. Together with that, we use Southeast Asian pricing. And we've heard that 30% from our top clients in the US, that's what they see. They see 50% faster, 30% cheaper. And that's why they come to us. Yeah, and another point to add on is the Southeast Asian capacity is not so easy to tap on. You need to be here in order to get to them. Like when I go to Vietnam to meet Vietnamese suppliers, it takes having beers with them to gain their trust. But if I go to Indonesia and I try and do the same, they don't drink, some of them. So.
Okay, so actually I have another question. Is it a scalable company if you need to drink beers with everyone you?
Early stage, yeah. That's a good idea. I actually tried wearing the batik to go in, but it didn't work either.
Thank you for that. I loved that as well. So I bet you enjoyed the tea break later on. So, ladies and gentlemen, if there are no other questions from the judges, that will mark the end of our first session. And the round of applause. All right, we have gone through 6 of our startups now, and that will conclude the first half of today's pitching sessions. So let's take a short 20 minutes break before we move into the next 5 of our startups: Fehrmann MaterialsX, Pelagus 3D, Qarbotech, REVIVO Biosystems, and Syenta. So be back here at 4:50 to catch the second session.